just write a couple down and write the answers for them and see if anybody can pick out the pattern to what I'm doing. Okay? All right.
Can't see the one below cosine.
There you go.
I kind of understand sine and cosine, but one below cosine, I don't really understand.
That's also sine.
Oh, okay, never mind.
Those are the answers. So this is what the problem would give you. These are the answers. Can anybody see what I'm doing?
They're the angle.
Good. Who was that, Kendall?
Yes, ma'am.
Extra credit. Good job, babe. They're the angles. I want you to think back to unit 4. Everybody just watch. In unit 4, didn't I give you something like this? So I gave you the angle in unit 4, and this is saying find the cosine at this angle, right? Cosine inverse. What do we know about inverses? Don't write this down. I don't want you writing this. How is it the opposite? Talk to me. What do we do with inverses? Good, good. Switch the x and the y. So the input is no longer the angle. The input is going to be the value. The output, the answer should be the angle. We're just working backwards. Does everybody understand that? That's all we're doing today. I'm not kidding. This is all we're doing today. Because you have to know this to be able to do everything else this week. Okay? So let's review. Good job, Kendall, Brody, KJ, Chris. Excellent work. Let's review inverses really quick. I want this in your notes. Inverse functions have flipped inputs and outputs. So remember all the way back to unit 1, when we were finding inverses, I had you switch x and y, correct? Okay. I'm gonna put that down here for those of you that want to see that. Switch x and y. Everybody okay with that? Okay. So then the next thing we need to recall. In unit 4, we learned how to find trig values from angles, right? So in unit 4, we were given an angle. Chris, I'll read it to you because I forgot that the green is not easy to see. In unit 4, we were given an angle and had to find a trig value. So with inverse trig, what am I going to be given? The trig value, good. We are given a trig value, and what are we going to be finding? Good. Do we feel like we can do that? If you know your hand trick or you know your patterns of your unit circle, you should absolutely be okay with that.
So this is where knowing like the negatives.
Exactly. Yep, you're actually leading into the last quote unquote notes we have for today. So this is where she said it's important to know what quadrants things are negative in, right? Okay, I think I'm going to teach you this next part by just writing an example so we can talk about it. So just to be clear, I'm gonna turn on my video for a second so my people at home can see me. Even though it's dark, we have the lights off today. To be clear, in unit 4, when I gave you angles, none of the angles are the same, right? Every angle is its own angle. Does everybody agree with that? Okay, can any of the values be the same? Yes. So let me give you an example. Let's do, let's just do this one again. But I'll make it negative. So here's the other catch with these. On the final exam every year, there's a question just like this. And it doesn't ask you to find the angle. It will literally say the following. So y'all make sure you listen because I'm not writing it. It will say, which of the following answer choices is the correct sentence to describe the inverse trig function? So let's talk about what this means. What are we trying to find? The angle. So you would look for, find the angle. I'm just going to do the symbol. I'm going to leave some room. Leave some room. Whose sine equals what? What should the sine equal? -1/2. That's the value. We're looking for the angle. That is what this means. Find the angle whose sine is -1/2. You're looking for the angle. We're just doing the opposite, the backwards, like Chris said. That's what an inverse is. Okay. Now, what's wrong with the, not wrong, what's tricky about this? The negative doesn't make it tricky. What 2 quadrants is sine negative in? 3 and 4. Remember, sine is the y values. Y's are negative in quadrants 3 and 4, right? How do we know which one to pick? Huh? Well, yes, we know we're finding the y. We know the sine value. Do I want the one in quadrant 3 or 4? Oh, perfect. We don't know. Here's the issue with that. In unit 4, we're talking about functions, right? Every input should have how many outputs?
1.
1. So we do know which quadrant we want. I only want one of them. Which one do y'all think? Just think about it. Which one do you think I would want?
4.
Why 4, Kendall? Or were you just guessing?
I just like quadrant 4.
So you're just guessing.
Yes.
Okay. What do we know? It is negative in quadrant 4, so that's a negative in quadrant 3. What do we remember from unit 5 about sine functions?
They are.
Think about the graph. What do we know about the graph of a sine function?
They're odd.
Good. Oh, it's odd. Odd functions are symmetrical across the x-axis. This way. Everybody can see me, right? So for odd functions, we're only going to be looking in quadrant 4 and 1 because this is where they're symmetrical. So let's think about it. Where are even functions symmetrical? What kind of symmetry do they have? across the y-axis this way. So what two quadrants am I going to look for for even functions?
2 and 3.
Oh, what? Even functions? Y'all are all saying wrong stuff. Good job, Oswald. Right here, top ones, 1 and 2. And then odd would be 1 and, I'm trying to show you the reflection here. This is where it's symmetric, okay? All right. Does everybody understand why we can only look in 2 quadrants? What happens if we're looking in all 4? You get
We could get like different angles.
Yeah, you get 2 different answers. This is supposed to be functions though, which means each input should have how many outputs? Just 1. So does everybody understand why we have to look in only 2 quadrants? You can't get more than 1 output. If I just give you this, then you guys could tell me, all right, use your hand trick, look at me. The sine, the y value is 1/2 at that first angle, which is what? Pi over 6. Pi over 6 is negative, the sign, in 3 and 4. So I don't know which one to pick unless I restrict it. If it's negative, we know it's got to be in quadrant 4 because this is odd. Does that make sense? So when we are looking for this angle for an odd function, we're going to look between negative pi over 2 and pi over 2. Between negative pi over 2 and pi over 2. Because it is an odd function. It is symmetric from unit 4 to unit 1. Now, because I know somebody's going to ask it, I'm just reading y'all's minds today. This is my favorite unit because it makes you think if you couldn't tell.
Yeah.
I did not say 0 all the way to 2 pi. You can't do that because then I'm including what quadrants? All of them. I only want 1 and 4, and it's a function, so it has to be continuous. There's no asymptotes or anything. It's got to be continuous. So if I want it to be continuous from quadrant 1 to quadrant 4, that means I can have the positive angle or the negative, and that's it. Are y'all following me? Because I always have kids not understand this part, and this is the most important part. Because if you're not looking in the right quadrants, you're not going to get the right answer. Does everybody agree? Y'all got to ask questions today because this is always the unit where my kids decide that they don't want to know anything. So y'all tell me the sine is 1/2 at pi over 6. So if it's negative and it's odd, we're going to look in quadrant 4 for the negative angle, which would just be negative pi over 6. That's the answer. That's all we're doing today. But I need you to understand what quadrants we're looking in. And then you have to know your unit circle. You have to be able to find those values. Okay?
Oh, wait,
So-
so we're not giving the radian?
Do what?
So we're not giving the radian?
That is the negative pi over 6. That's the angle.
Why isn't
Oh,
it?
I said 11 pi over 6.
Yeah, that's what I was going to ask.
So did y'all hear what I just said? Can somebody in class answer them? Why is it not 11 pi over 6? If I start in quadrant 1, does everybody agree that starts at 0? And it goes to pi over 2? Yes? Does everybody agree? Okay. Quadrant 1 is 0 to pi over 2. It is a function, meaning we know sine functions should be continuous. So I can't go from 0 pi over 2 union 3 pi over 2 to 2 pi. Is that continuous? Nope.
No.
So you can't put 11 pi over 6. The continuous interval that contains quadrant 4 and quadrant 1 is negative pi over 2. So start down here, but go this way, and then go all the way up to pi over 2. That gets quadrants 4 and 1 at the same time and makes it continuous. So if it is odd, your options are going to be the positive angles in quadrant 1 or those same angles in quadrant 4, meaning they'll just be negative. Does that help, girls?
Yes, I get it.
Okay, good. That's really the only notes for today. And I'm just gonna do a crap ton of examples. So let's make a table really quick to make sure we are all on the same page. And then we'll do examples. People at home, just unmute and ask a question if you have one. It is very different if you wait till tomorrow or even Thursday to ask your questions, not to sound scary, but it'll be too late. You'll be too far behind already. Already. Let's start with the odds because we already talked about those. What are my odd trig functions? No, not angles. The trig functions themselves. What are the odd ones?
Sine and
Thank you, Kevin. Sine.
Cosecant.
Thank you, Kendall. The reciprocal cosecant is also odd because it goes with sine. There's one more.
Cotangent.
The reciprocal.
tangent.
Yeah. These are your odd trig functions. Sine, cosecant, and tangent. If you graph them, they have origin symmetry, meaning they are odd, meaning we want quadrants 1 and 4. So for these three, what is my domain going to be in between? What am I looking in between? Negative pi over 2 and pi over 2. It's got to be an angle in quadrant 4 or quadrant 1 if it is odd.
Never mind. Wait, I get it. Never mind.
Okay.
I was thinking about it in terms of the unit circle graph, and I was like, wait, but those are on the y-axis.
Functions. Think about the graph of the functions themselves that we did last unit. So it also ties in unit 5, which is why I love it. Quadrant 4 to quadrant 1? Okay. So then what are our even trig functions? Cosine, which you knew from last unit. Secant, which you knew from last unit. The only one we didn't talk about, I didn't show you why it was even. I can show you in office hours if you, excuse me, I got the hiccups, if you would like. But cotangent is actually even. So the only two that don't go together are cotangent and tangent. One is odd, the other one is actually even.
Is that why you can do the never mind, because you can do that for the sine for all of them.
Okay.
The asymptote trick.
Yeah, so these do have asymptotes, but that doesn't have anything to do with inverse trig.
Okay.
Because inverse trig, I'm giving you a value, we're finding the angle. I'm not worried about asymptotes. So listen, if you want to know why cotangent is even, just pop in office hours today, or you guys can come see me after school before you go home. Okay? Okay? So if it's an odd function, it's symmetric about the origin, meaning when you look at the graph, it'll be reflected in quadrants 1 and 4. And so that's just the angle from the bottom of quadrant 4 up to quadrant 1. We're looking for an angle between negative pi over 2 and pi over 2. Exactly, and it wouldn't be continuous. Yep. So let's talk about these then, since you just asked that question. If these are even, what kind of symmetry did we just talk about them having? Think about a parabola. Over the y-axis, which means in quadrants 1 and quadrant 2. So listen, what is the continuous range of angles, the continuous domain of angles from quadrant 1, the beginning, to the end of quadrant 2? 0 to pi. Good, Oswald. So I'm going to be looking for my even functions for an angle between 0 and pi. Quadrant 1 to quadrant 2, because they should have y-axis symmetry. Does that help, KJ? This one is usually easier for y'all to see because you're used to like polynomial functions like quadratics. This one's a little bit harder to see. And it just throws y'all off because it's negative. Do we understand though why it's the negative to the positive? You can't include quadrants 2 or 3, so I can't go all the way around positive. I can go here or here. I feel like we just need to see some examples.
Yeah.
Okay, let's do it. I can do one of each kind, and then if we need more, we can do even more. How does that sound?
Fine by me.
Does that sound good to everybody else? All right. People at home, just unmute if you got something for me. So for all of these really quick, I also want us to practice writing the sentences because I'm not kidding. Every year that I have taught pre-cal, that is an exam question. Which of the following correctly describes the inverse trig function? So I want us to be able to write the sentence for it too. So we're going to write the sentence for the meaning, and you know you guys can abbreviate, and I'm usually fine with that as long as I can tell what you're saying. Then find the angle. Sorry, that's a little sloppy. I'm telling you, Natalie, I used to have that really good handwriting. All right, let's start off with a different one this time too. Where's my pen? Let's do. I love it, Chris. You're already thinking about what the answer would be. That's beautiful. Do y'all want to write the sentence first? I feel like that might help some of y'all know what we're looking for. Okay, cosine inverse of 1/2. If you see an inverse trig function, that means we're trying to find the what? Angle. Good. I'm scared because he's the only one answering. Hang on, Chris. No. We're trying to find the angle. Does everybody agree? Because it's inverse trig. I gave you the value. We're looking for the angle. So look, we're going to find the angle between what? Because there's 2 places on the unit circle where this is positive. So look at your cosine. Is that even or odd? Even. So what are the only 2 quadrants I'm looking in? 1 and 2. So between what and what? Good, Oswald. 0 and pi. Find the angle between 0 and pi, whose cosine equals 1/2. That is the sentence you should write, something along those lines. Now I have people in class saying the wrong thing. So I'm going to throw my Michael Jordan, Shaquille O'Neal hands up here. I wore heels this weekend. My husband said, "You look so cute." And I was like, "Thank you." And then he was like, "Shaquille O'Neal." And I was like, "Boy, I'm about to deck you." Y'all didn't ask. It was just a funny story. I had to tell you. All right, here's my big sporty hands. Everybody ready? Okay. The cosine is 1/2. Let's just think about quadrant 1 right now. And then if we need to look in quadrant 2, we can. The x's should be 1/2. Meaning my fingers above the angle should just be 1. You have 2 hands. Do you guys remember me teaching you this hand trick? It wasn't because I like looking at my hands underneath this. It's because it works. The x value should be 1 over 2 hands. So I'm going to put this finger down. There's my x value of 1/2. What angle is that third angle?
Pi over 3.
Good. Pi over 3. And now let's talk about it. At pi over 3, is the cosine going to be positive? Yeah, in quadrant 1, everything's positive. So if you see a positive cosine, you don't need to go looking in quadrant 2. What are the x's in quadrant 2? Negative. We want a positive, so we're going to stay here in quadrant 1. So what is the angle that has an x value, a cosine of 1/2? What was this angle? That's the answer. You're done.
What's up? 1 over 2.
If it's 1/2, that means you have one finger above the angle. There's 2 hands. That's everything is over 2. You have 2 hands. So 1. Remember the other option, because the square root of 1 is 1. The other one is square root of 2. 2 above, 2 below. And the other one is square root of 3. This one is a whole 1 because the square root of 1 is just 1. Okay? Let's do another one. It's just going to be lots of examples and practicing. This stuff just takes practice. Let's do... Let's do another cosine, just to make sure y'all are good. Cody, you with me, babe? Okay. All right, let's write this sentence first. What are we looking for? The angle. Okay, good. Why is it between 0 and pi, KJ? Because it's even. So we're looking in quadrants 1 and 2. Whose cosine should be what? Negative square root of 2/2. So let's stop and think about it really quick. If the cosine is negative, what quadrant are we going to be in? Okay, so we know we're going to look in quadrant 2, right? All right, so square root of 2/2. That's the easy angle. That's the one right in the middle. Does everybody agree? Right in the middle? Square root of 2/2, square root of 2/2. So it doesn't even matter if we're talking about sine or cosine, because that middle angle, they're the same. Who remembers what that middle angle is? Good, Chris, pi/4, but what quadrant are we in? So what is the pi/4 angle that's in quadrant 2? Good.
135.
Or 3 pi/4. Kendall, they will more than likely use radians. You'll find out why next unit, okay?
Okay.
So I'm going to do all radians. It is 3 pi/4 or 135 degrees. That's it. That's the answer. We found the angle between 0 and pi, whose cosine was negative square root of 2/2. So we just got to know that hand trick. Do you see why I said that was so important now? All of you in Unit 4 that just flipped back in your notes and used your notes for the test, I know. Because then when I called y'all into the Zooms to go over your test, you couldn't tell me the trig values. I was like, this little booger stared at their notes the entire test. It's a bad thing about virtual learning. All right, let's do a sine one. Why not? We already did that, so let's do this. I'll be good. Sine inverse of -1. So let's write our sentence first. What am I looking for? The angle between what for this one? Good. Ross, why is it negative pi/2 to 2 pi, or pi/2, excuse me? Oh, I hate that answer. Somebody help him. Because it's odd, so it should be in quadrant 4 or quadrant 1. Very good. Whose sine? Ross, you know I love you. Boy said, I don't know, I just looked at my notes. Whose sine is -1? I gave you an easy one. Please don't miss the ones where I'll give you 1 or -1. Where is the y value? -1 on the unit circle. You don't need your hand for this. Why are we saying crazy stuff? It's not in a quadrant. Where's the y value -1?
On the
The
y.
y-axis.
Thank you. On the negative y-axis. What's this angle?
3 pi/2.
Okay, good. Grace said it's 3 pi/2. Can I name it 3 pi/2? No. So watch. Everybody watch. If you name it 3 pi/2, that means we went this way. What 2 quadrants did I just go through? And I can't have 2 and 3. It has to be between 1 and 4. So which way can we go to get to this? Right here, which would be
Negative pi over 2.
Good. Yeah, that's exactly why you shouldn't have used your notes so much in Unit 4. I tried to tell y'all. Negative pi over 2. Instead of going up pi over 2, I just went down the opposite way. That one should be easy. If I give you a 1 or a -1 or a 0, please don't miss that. That's one of your 4 quadrantal angles. One of your quadrantal means one of your angles on the quadrant. On the border. All right, let's do some more. I'm going to keep going. I'll probably do like 5 or 6, and then I'll turn y'all loose to try a couple before we do homework. How's that sound? I'm having to think. All right. Are y'all okay? Okay. Some of you look very, I don't know a good word, like frustrated maybe, or upset or stressed. What are we looking for? How would I start my sentence? What's good, Dre? Why is it between negative pi over 2 and pi over 2? I'm gonna keep quizzing y'all because it's sine and it's odd. Good. Whose sine equals what? All right. Let's think about it before we even get started. If you can figure out what quadrant it's in before you even get started, you'll make it easier for yourself. We're looking in 1 or 4. Where are the y values negative between quadrants 1 and 4? 4. So we know it's going to be in this bottom one. We also know we can't go all the way around to get to it. We've just got to go down. So what kind of angle is it going to be? We know it's going to be a negative angle. Very good. Now let's just figure out which one. You're so smart. I'm so proud of you. Extra credit. The y value should be 1/2. So look at my hand. Michael Jordan. All right. The y, I want 1 finger because it's 1/2. Square root of 1 is 1. I want 1 finger below the angle. So that means I'm at this very first angle. Correct? Okay. So this is where the y is 1/2. What's that very first angle? Pi over 6. And Chris is saying it's negative because we know we should be in quadrant 4.
Didn't we already do this one?
We did the positive version. Did I do this on the front?
Yes, ma'am.
Wow, then I'm very upset that y'all just looked so confused. Good job, Kendall. All right, I feel like I can step it up. If you feel like I can't step it up, that means 1 of 2 things. 1, you need to ask a question. Or 2, you don't know your unit circle, which means you got some work to do. You can come to office hours, we can work on it. It's just like, it's not Kayla up here. I know Kayla's up here. Right? Yes, Kayla.
Yes, ma'am.
Coach Duck stays having you do free throws, and everybody runs sprints for how many you miss, correct?
Yes, ma'am.
My boy used to kill me. Whew, I understand. Taryn, just like y'all used to serve till we hit 50 in a row and everybody would run. It takes practice. You got to keep practicing, okay? All right, let's step it up. I'm excited to step it up. We got a cotangent up in here. You know I'm going to make you do a sentence first, just so we know what we're looking for. So what am I looking for? Good. Why is it between 0 and pi? Good, because it's even. If you want to see the proof behind that, come to office hours. I think most of you are just going to take my word for it. But I would love to show you why it's even. Find the angle between 0 and pi, whose cotangent equals 1. So listen to me carefully. If the cotangent is 1, what does that mean the tangent was? What? What happens when you flip 1? You still get 1. Thank you. So we're trying to find where the tangent is 1. Right? Okay, we're looking in quadrants 1 or 2 because it's even. What do we know about the tangents in quadrant 2? They're negative. Good, Drake, because in quadrant 2, you have a negative x and a positive y. So when you do positive y divided by negative x, you're going to get a negative. What do I want? So what quadrant am I looking in? Quadrant 1. Good. Is everybody okay with that part? What angle, when I divide the y and the x, do I just get 1? Remember at pi over 4, it's just square root of 2 over 2, that's the x, and the y is square root of 2 over 2. So when you divide them, you should get 1. Okay, I'm gonna keep going. People at home, I feel like a broken record today, but if you have a question, please just ask me. Yep. Talk me through my sentence. Find the angle between what? Good, because it's odd. We're looking in quadrants 1 and 4, so negative pi over 2 and pi over 2. Where the tangent should equal negative square root of 3. Do you guys remember? Wow, it was a long time ago. It was like 3 weeks ago when I showed you that tangent trick for remembering which value goes with which angle for the tangent.
I'm gonna go out here. Is it 5 or 3?
It is, Chris, extra credit. Oswald, extra credit. I showed you in unit 4 a trick for the tangents, and I said you don't have to use it now. You can divide the ordered pairs, but when we get to unit 6, you're gonna want to know the trick. So I'm gonna write it over here. If you need a refresher, you can copy it down. At pi over 3, every single time you divide the y and the x, you should get the square root of 3. Who remembers at pi over 6 what we'll get every single time when we divide y over x?
Pi over 3 over 3.
Square root of 3 over 3. Good. Very good. So if you know that, this should be really easy. I gave you, hang on. I gave you square root of 3. So Chris said, okay, that's 1, 3. That means it's at pi over 3. Now, Chris, it's negative, which means we're in what quadrant? 4. So what should my answer be? Very good. Negative pi over 3. All right, who was going to say something at home?
Oh, I was just gonna say what you're about to say because in the pi over 3 there's 1 3, and in pi over 6 there's 2 3s.
There's 2 3s, which makes 6. That's the corny trick I taught you, and I said it's really going to help out in unit 6. Very good, Grace. You remembered the corny trick. Me and you are on the same wavelength sometimes, which scares me. It should scare you too. Oh, that was a compliment. Good job, Grace. All right, how many more do we think we need? Can I give you like one more? And then you guys can start homework. This is all you're doing on the homework. You'll write the sentence. You'll find me the angle. Oswald is so happy. He's like, this is easy. You really look, that's the most I've seen you smile all semester. Okay. I'm gonna make it a little tricky. Nobody's gonna freak out because it's gonna be totally fine. Cosecant inverse No, don't do that. I didn't make you memorize cosecants for a reason because some of them end up being crazy. Miss Kane used to make us memorize all of them. It doesn't work. Then you got too many things in your head at once. So let's worry about what quadrant and all of that jazz in a second. Can we set up the sentence?
Yes, find the angle between negative pi over 2.
Perfect. Find the angle between negative pi over 2 and pi over 2, whose cosecant equals that crazy number, 2 square root of 3 over 3. Now, because I know somebody at home is like, oh my God, I don't know this. I'm going to flip back in my notes, or somebody in class, but I'm here to make fun of them if they do it. It's out of love. I'm not bullying you. It's out of love. Don't go home and be like, my teacher bullied me today. All right. I did not make you memorize cosecants. There's no need to memorize this. What is cosecant the reciprocal of? Sine. So everybody, let's all do this together. Can you flip this number for me?
Yes.
Thank you. God, that took y'all a while. Okay, so let's flip it. Now, are we allowed to have a square root in the bottom? So how do you get rid of it? Rationalize. Do you guys remember doing this?
Yes, ma'am.
Okay, good. I'm hearing yes, ma'ams. I love it. So this would be 3 square root of 3 over, what happens with these square root of 3s right here?
They cancel out.
They become a whole 3. They cancel out. What's 2 times 3? What does this reduce to? Square root of 3 over 2. So we are just looking where the sign is square root of 3 over 2. Do we all know how to do that?
Mm-hmm.
Everybody should say yes. If I give you cosecant, secant, or cotangent, flip it, find the reciprocal, and look where the sine, cosine, or tangent is, okay? That's how I taught you to do it in Unit 4 also. So let's use our hands. The y value needs to be square root of 3, which means I should have 3 fingers below the angle. 1, 2, 3. So I'm putting this one down. I have 3 fingers below the angle. That's the y value. What angle is this? Pi over 3. And it's positive, so do I need to worry about quadrant 4? No, it's just pi over 3. Do we feel like we could do ones like that on your homework? Because you do have a couple. Majority of them are sines, cosines, tangents. I did give you 2 secants and 2 cosecants. Okay? All right, my in-class people.